Section 2.3, factoring expressions. Okay, so we're moving away from multiplying expressions and expanding them out and talking about factoring them. Okay, so what do I mean by factor? To factor an expression is to transform it from a sum of terms into a product of factors. Okay, so that's a lot, that's a dense definition there. So let's kind of break this apart a little bit. Remember, sum means addition, right? You're adding things together, and we're lumping addition and subtraction together kind of as the same operation. Okay, sort of, right? When we talk about terms, we're talking about things like 15x and 14, right? These are just individual terms. They are usually a number and a variable held together by multiplication, right? Well, if it has a variable, it's considered a variable term. If there's no variable, it's considered a constant term, right? But they're individual terms. Okay, so we're talking about a sum of terms like 15x plus 14. There's a sum of terms right there. Okay, if we try to transform it into a product of factors, okay, product means multiplication here, and factors, things that are being multiplied together. Okay, so if I'm looking at 14, just the number 14, and I wanted to factor it, okay, I could rewrite that as 2 times 7, right? So in a way, I've factored the number 14. It's into its prime factorization. I can even factor terms like 15x, right? That's 15 times x, right? And we could say that 15 is also 3 times 5, so I can go a little bit further and say 3 times 5 times x, right? These are just different ways we could factor these individual terms here. Okay, so now we want to factor collection of terms, right? Terms that are added together. Okay, so that's what we're getting into. So let's go ahead and get to a good example here. You'll see that this is the same example twice, just written out in different ways. So 2x squared times 3x to the third power plus 5. Well, in the last section, if you would have seen that, you would have known to multiply, distribute that 2x squared times 3x to the third power. 2 times 3 would be 6, and x squared times x to the third power, you add the exponents together and get x to the fifth power. After that, you would multiply 2x squared times 5, right? You're distributing the 2x squared. Okay, well, 2 times 5 is a positive 10, and there's an x squared, right? This one didn't have an x, right? There was no x attached to that 5 there, but when you multiplied this 2x squared over here times a 5, you brought that x squared with it. So my product there is going to have the x squared as well, right? So I multiplied it out. You might notice that that looks a lot like this problem here. Okay, well, there's a reason why I'm doing that. I want you to see the connection, okay? If you're given a problem like this and asked to multiply it out, you distribute and you get 6x to the fifth plus 10x squared. But if you were given an expression like this one and you're asked to factor it, you need to undistribute. You need to figure out how do you take this 2x squared out, okay? Well, first you need to learn to recognize that there's a 2x squared in there. Okay, so let me do this really gross example of factoring, so that way you can kind of see what's going on behind the scenes, and we'll figure out a more efficient way to do it. But for now, let's do it the ugly way. So 6x to the fifth. Well, 6 is 2 times 5. I'm sorry, 2 times 3. X to the fifth power, so 5 x's, right? 1, 2, 3, 4, 5. This entirely represents the 6x to the fifth power. Okay. 10x squared, put my plus sign, 10x squared, 10 is 2 times 5, and x squared is x times x. Okay, all of this is representing that 10x squared. Okay, so if I'm looking through this for a common factor, right, factors that they have in common, right, it's like by definition, I'm looking for this has a 2, and this has a 2. This has an x, this has an x. This one has an x, this one has an x. I can pair them up. Notice what they're paired up with. 2 x squared, 2x squared, right? That's how we are going to find the common factor. Okay, so 2x squared is my common factor. Okay, so now let's look back through here. We know we're going to need parentheses, right? I mean, you have the factor on the outside and you have something inside the parentheses there. To figure out what goes in the parentheses, let's look at what's left over once I've factored out the 2x squared. Okay, there's a 3, an x, an x, and an x. That's 3x to the third power. 3x to the third power. Plus, this I'm left with a 5. Notice we have factored it. We've gone back to that right there. Okay? So, when factoring, you are trying to figure out what is the common factor, what is the greatest common factor that they all have. Write that on the outside of the parentheses. The leftovers go to the inside of the parentheses. Now, another way to look at the leftovers, right? This 3x to the third power. I could look at that and say, well, I took out the x and the x here. Another way to think about it is I kind of divided them out in a way. So I want you to be thinking like division is taking place. Let's look at it a little bit closer. Okay. If I were dividing 6x to the fifth by 2x squared, right, the common factor here, well, 6 divided by 2 is 3, and x to the fifth divided by x squared, you remember you would subtract your exponents here, 5 minus 2 is 3. That would give me x to the third power, right? So that's going to be our mental strategy. Okay, now let's focus on finding the greatest common factor and factoring that out of an expression. So we have 15x to the fourth minus 10x squared. Okay, it's really 2 steps to finding the greatest common factor. The first is to ask yourself, of the numerical parts, right, the numbers, 15 and 10, what are they both divisible by? What number? And the answer to that is 5, right? 5 divides evenly into 15 and into 10, right? So 5 would be part of my greatest common factor. The next thing is to look at the variables. Both of these terms are variable terms. They both have x, they both have an x, right? This one has 4 x's, this one has 2, but they both have at least 2 x's in common. So I would say x to the second power is my common factor among the variables, right? So 5x squared is my greatest common factor. Okay, now I guess something else I want to point out. If they both have a variable, you're really just focusing on the one with the smallest exponent. Okay, that'll tell you which, like how large your exponent should be when you factor it out. Okay, anyway, so now let's do the division part, right? Now again, this is technically not mathematically correct. We would never say write it like this, right? But it does get the point across. You are factoring out 5x squared. So you're dividing those factors out of the term. So I'm gonna delete that for now, but understand that's what we're doing here, right, in our minds. 15 divided by 5 is 3. X to the fourth divided by x squared. Remember, you subtract your exponents. 4 minus 2 is going to be 2. So that's going to leave me with 3x squared. Okay, now let's divide this one by 5x squared. Well, that's a negative 10 divided by 5, which is negative 2. And x squared divided by x squared, well, those cancel out, right? You'd get 2 minus 2, which is 0. X to the 0 power, meaning I have no x's present. Okay, so there we go. We have 5x squared times 3x squared minus 2. Okay, let's do this one now. Now we have 3 terms. Okay, we have to focus on all 3 of them. So I'm again looking at just the numerical part. Negative 4, negative 6, and positive 2. All of those are divisible by 2. Okay, now I'm looking at x to the fifth, x to the second, x to the third. X to the second has the smallest exponent, so we could say that they all have at least 2 x's in common. Okay, so now let's divide everything by 2, x to the second power. So negative 4 divided by 2x, well, negative 4 divided by 2 is negative 2. X to the 5th power divided by x squared, 5 minus 2 is 3. X to the 3rd power. Negative 6x squared divided by 2x squared would be negative 6 divided by 2 is negative 3. X squared divided by x squared is just 1, right? They cancel out. So that would be 3 times 1, or just 3. Finally, 2x cubed divided by 2x squared. 2 divided by 2 is 1. And x cubed divided by x squared, subtract the exponents, you get x to the 1st power. Okay, so here's one way we could write out the answer, perfectly acceptable way to do it. Another way to write out this same answer though, let's kind of work through this problem again. Matter of fact, what I'll do here is just bring this down because I want to look at this problem again. Yes, 2 is a common factor and x squared is a common factor. Notice though this first number here is a negative. If that happens, it's usually best to factor out a negative with it. Okay, so instead of taking out 2, take out a negative 2. Now that's not going to change much, but it's going to make a big difference. I guess that sounds kind of contradictory, but we'll see. If you divide negative 4 by negative 2, you get a positive 2. The x's will be the same, right? If I divide a negative 6 by a negative 2, I get a positive 3. The x's stay the same, right? And then finally, if I divide this by negative 2x squared, I'll end up with a negative 1x, or negative x. Okay, both of these are acceptable answers. Okay, they're both factored. These are the same. The only thing different is this one's technically preferred. The top one's preferred because in the parentheses now you're starting off with a positive number instead of a negative. Okay, and that's useful down the road. Okay, let's talk about factoring trinomials now. Now these are more common. These are the ones that you'll usually see. And they're more difficult to work through. You're not only looking for the greatest common factor anymore, you're going to have to do an entire process to factor it out. Okay, so we're trying to take trinomials and rewrite them as the product of binomials, okay, or at least something along those lines. 4n squared minus 11n minus 3. Okay, we're going to start with this problem here. All right, this is called the AC method, and what we're going to do, and first of all, let's recognize when you can do this. You have a variable term here that's raised to the 2nd power, followed by another variable term, but raised to the 1st power, followed by the constant term. So it's set up like this. Oftentimes people will say that's A, B, and C. It's called the AC method because you start off by multiplying the numbers A and C together. So in this case, 4 times negative 3. So, 4 times negative 3 is negative 12. So I need to rewrite this entire expression here as 4 terms. Rewrite it as 4 terms. My goal is to split the middle term into 2 terms. Okay? And so again, it'll make more sense as we go. But start off by multiplying 4 times negative 3 and get negative 12. Now we need to find a pair of numbers that multiply together to equal negative 12, but when you add those same 2 numbers together, they add up to this middle negative 11 here. Okay, the B term, right? So this is A and C multiplied together, this is B. Okay, so now, numbers that multiply together to be negative 12. Negative 2 and 6 multiplied together to be negative 12. Negative 3 and 4. Negative 1 and 12. Okay, all of these multiply together to be negative 12. And there's more, but let's see if we need to. So, negative 2 plus 6 is 4. Remember, we need them to add up to negative 11, so we're going to say that 4 is not good. Right, that's not negative 11. Negative 3 plus 4 is 1. That's not negative 11. Negative 1 plus 12 is positive 11. Okay, we're getting closer. That's still not right. So if you get the right number, but the wrong sign, right? So I have a positive 11, but I need a negative 11. Just flip your signs around. So instead of having a positive 1 a negative 1 and a positive 12, we're going to go with a positive 1 and a negative 12. Those add up to negative 11. So that's my pair of numbers I'm going to work with here. Okay, like I said, I want to split that middle term into two terms. Let me write this out again. 4n squared plus 1n, put that in blue, plus 1n, the 1 is not necessarily something you have to write out, minus 12n, or plus negative 12n, minus 3. Notice I brought down the first term and the last term. This middle term split into two. You can see the relationship between each line here, right? You can see how this line connects to this line. If you were to combine these two terms together, 1n plus negative 11n, or negative 12n, you would get negative 11n, right? So those are, that is what we get when we try to split negative 11n into two terms. Okay, so why do we want to do that? Okay, so this is the next step. We want to group. We want to group together the first two terms and the last two terms. So I'm just going to write it again just with a little bit more space so that I can group together the first two terms and group together the last two terms. Okay, so now 4n squared plus 1n grouped together plus negative 12n minus 3. Now I want to look for the greatest common factor in each of these sets of parentheses. Okay, find the greatest common factor in each of them and factor it out. Okay, so 4n squared plus 1. 4 and 1, the only thing they have in common is 1, right? The only common factor is 1. But they both have a variable. Each term has a variable. And the lowest exponent on those variables is the first power, right? This one. This one has n to the first. So we have 1n. I'm not going to write the 1, but 1n is my common factor. Now let's say I factor that n out. I divided it out. If I divide 4n squared by n, again, that's n to the first power, so subtract 2 minus 1 and get the first power again. I get 4n. If I divide this one by n, the n's would cancel and leave me with just plus 1. Now, negative 12n minus 3. 12 and 3 are both divisible by 3. Now I could take out a positive 3 or a negative 3, but we just talked about how you want that first number in the parentheses to be positive, right? So we're going to factor out a negative 3. Okay, again, if this is a negative right here, take out a negative number. Okay, so, oops, wrong color there. All right, so if I divide this by negative 3, that's going to be a positive 4n. If I divide this by negative 3, it's a positive 1. Okay, now it looks like I'm doing things correctly, right? I'm not done yet, but notice I have these two terms here, right? N times 4n plus 1. That's technically a term because it's things that are multiplied together, that are, well, it's something held together by multiplication. And here's another term here, negative 3 times 4n plus 1. And look, they're separated by a sign, right? A plus or a minus. So I have these two terms. Of these two terms, they have a common factor. 4n plus 1 is a common factor among both of them. So 4n minus 1 is now my common factor, so you know where you put that. You put that out in the front. And then you have some blank parentheses where you put the leftovers, right? So think about it. If I divided out a 4n plus 1 here, this is gone, leaving me with n. And if I divided this by 4n plus 1, these are gone, leaving me with minus 3. So n minus 3 goes in the remaining parentheses. So there we go, we have factored it. 4n plus 1 times n minus 3. That is the same thing as this expression here, except this one is written as terms, right? This one is written as factors. It's factored out. Okay, so that is a process. Let me kind of run through that again really quick. Our first step was to find two numbers that multiply together to be whatever these two multiplied together to be, which was negative 12, and add together to be the middle number, negative 11. Okay, the goal of that was to split the middle term into two terms. because I wanted to have 4 terms. You need 4 terms so that way you can group together the first 2 and the last 2. Once you group together the first 2 and the last 2, you factor out the greatest common factor. In this case, it was an n. In this case, it was a -3. Once you have matching parentheses, which you should, if your parentheses don't match, that means you messed up somewhere in this step, most likely. Once you have matching parentheses, they factor out together. The leftovers go in the second set of parentheses. Okay, I would recommend that you probably watch that a couple of times to get that process down, and whenever you are going through the homework, I would recommend that you watch the little individual help videos for those if you get stuck. Okay, let's go through this again. Let me kind of draw a line here. Let's go through this again with this problem here. X squared minus 10x plus 24. Okay, so I need to find 2 numbers that multiply together to be, well, let's start off by saying understood 1 times 24 is 24, but add together to be the middle number, -10. Okay, I need to multiply together to be 24, but add together to be -10. Okay, so I'm going to look through some numbers here like, 2 and 12. Those multiply together to be 24, but they add up to 14. That's not -10, so we're going to scratch that out. We could do 1 and 24. Those add up to 25, though, so that's not good. We can try 3 and 8. Those add up to 11. We could do 4 and 6. Those add up to 10, +10, so let's flip those signs around. -10. There we go, -4 and -6. So I'm going to use -4 and -6 to split the middle term, -10x, into 2 terms. Bring down the squared term. We're going to say -4x plus -6x plus 24. Okay, we have split it into 4 terms. Once it's into 4 terms, we'll group together the first 2 terms and the last 2 terms. Just rewriting it so I can set that up. X squared minus 4x plus -6x plus 24. Now, between x squared and -4x, I need to find a common factor. They both have an x in common. This one has 1, this one has 2, so they both have at least 1x in common. If I divided that x out, if I factor that x out, x squared divided by x, I'm left with just x. -4x divided by x, I'm left with -4. -6x plus 24. 6 and 24 are both divisible by 6. I have to decide positive or negative. This is a negative, so I'm going to put a -6 here. Divide by -6, and I get positive x. Divide that by -6, I'm left with -4. Okay, that's good because now my parentheses match. If your parentheses match, it's a common factor, so you can pull it out of this giant expression here. I'm left with x. Once I take the x minus 4 out of this one, I'm left with x. And once I take the x minus 4 away from this one, I'm left with -6. So we have x minus 4, x minus 6. Okay, maybe you noticed something there. Okay, maybe you realized that -4 and -6, -4 and -6, right? Okay, so to save time, you can skip all these middle steps and go straight to using this as -4 and -6 if there's an understood 1 in front of the x squared, right? So in front of that squared term, if it's a 1, right, there's no other numbers there, you can skip all those middle steps once you have your pair of numbers, and you can factor it out, okay? So don't get your hopes up, but it will happen, and it's better to be efficient, so just get there. Get there quickly if you can. Okay, let's just do a couple more. Each of these are special in their own way. Okay, so I want to go back real quick. The one on the left here, this is a standard factor a trinomial problem. This one is a standard problem, but you realize that you could take a shortcut, but learn to recognize when you can use it. Okay, let's talk about these two now. So 75x squared minus 10x minus 40. Okay, so that problem there, those numbers are big, and I really don't want to multiply 75 times negative 40 and start from there. Luckily, you'll notice all three of these terms are divisible by 5. Right? They're all divisible by 5, which means 5 is a common factor. I'm going to take that common factor out first and then see what I get. So if I divided 75x squared by 5, I would get 15, right? So 15x squared. Negative 10x divided by 5 is negative 2x. And negative 40 divided by 5 is negative 8. So I have 5 times 15x squared minus 2x minus 8. I'm going to focus on factoring this now, keeping in mind that this 5 is still going to be there. Okay? So I'm going to factor the inside part, but I'm going to keep that 5 on the outside. Okay, so what does that look like? Well, let's go ahead and do our AC method. 15 times negative 8 is negative 120. So I need two numbers that multiply together to be negative 120, but add together to be negative 2. And that's what I need. The first numbers that come to mind would be negative 10 and 12. Negative 10 times 12 is negative 120, but negative 10 plus 12 is 2. So although that's not the right number, I mean, it's the right number, but the wrong sign, right? So let me just flip my signs around. 10 times negative 12 is negative 120, but 10 plus negative 12 is negative 2. So I found that one pretty quickly, actually. 10 and negative 12. So I'm going to use that to split up the negative 2x. It's going to be 15x squared plus 10x plus negative 12x minus 8. And let's not forget, 5 is still hanging on the outside of all of this, right? So I'm going to put that there. Okay, so now let's group together the first two terms and the last two terms. X squared plus 10x is grouped together. Negative 12x minus 8 is grouped together. Let's not forget about our 5 hanging on the outside here. Now, common factor between 15x squared and 10x. Both are divisible by 5. Both have an x. Right? This one has 2, this one has 1, but they both have at least 1. Okay, if I factor out 5x, 15 divided by 5 is 3. X squared divided by x is x. 10 divided by 5 is 2. X divided by x is 1. 2 times 1 is just 2, right? So the 1 basically cancels out. Or the x cancels out. Alright, so negative 12x minus 8. 12 and 8 are both divisible by 4. And since this is a negative in the front there, I'm going to put a negative 4. Negative 12x divided by negative 4 is a positive 3x. Negative 8 divided by negative 4 is a positive 2. Again, don't forget, 5 is still hanging on the outside here. Okay, finally, we have matching parentheses, right? 3x plus 2. We have 5x minus 4 as leftovers. Right, 5x minus 4. And let's not forget, a common mistake here is to forget that 5 on the outside. 5 times 3x plus 2 times 5x minus 4. Okay, that was a longer problem. It was kind of ugly, but remember, it was made easier by factoring out the common factor in the beginning. So you should always check for a common factor before you do anything else. Okay, sometimes it'll make the problem easier. Okay, 3x squared plus 6x plus 4. Okay, again, this sets up for the AC method again. Let's check for a common factor. 3, 6, and 4. There's no number that goes into all three of those, and only the first two have a variable. This one has no variable, right? So there's no common factor that I can take out right away. Okay, so 3 times 4 is 12. I need two numbers that multiply together to be 12, but when I add them together, I get the middle number 6. Okay, so what could I multiply to get 12? 1 and 12. That would add up to 13. That's no good. Let's not neglect the negatives here. Negative 1 and negative 12, those add up to negative 13. We could do 2 and 6. Those add up to 8. We could do negative 2 and negative 6. Those add up to negative 8. We could do 3 and 4. Those add up to 7. Negative 3, negative 4 add up to negative 7. And I've run out of options. Okay, if I run out of options, we would just say that this is not factorable. At least not yet. Not factorable yet. Eventually we'll learn ways to factor that. Okay, but that's not where we are right now. Okay. Here's some other special cases here. 9x squared minus 1. So if I wanted to factor this, notice we're missing a term. And we need to fill it in, okay? So which term is missing is usually the question, okay? 9x squared minus 1. We have the squared term, we have the constant term. We're missing that middle term, right? The one with the x with only an exponent of 1. So let me rewrite this as 9x squared plus 0x minus 1. So that way I'm accounting for that middle term even though it's not really there, right? I have 0 there. Okay, I need to find two numbers that multiply together to be 9 times negative 1 is negative 9. But when I add those numbers together, they add up to 0, the middle number 0. Okay, and so what? 1 and negative 9, those add up to negative 8. Negative 1 and positive 9, that adds up to positive 8. 3 and negative 3. Those add up to 0, check. So we have 3 and negative 3. Okay, so 9x squared plus 3, or 3x I should say, plus negative 3x minus 1. Now I'm going to group the first two and the last two terms together. Group together. The common factor between 9x squared plus 3x, well, 9 and 3 are both divisible by 3, and they both have an x, at least x to the first power. 9 divided by 3 is 3. X squared divided by x is x, plus 3x divided by 3x is 1. Okay, now negative 3x minus 1. The only number they have in common is 1. And we're going to take out a negative 1 because of the negative in front of, well, in front of the 3x. Negative 3x divided by negative 1 is a positive 3x. Negative 1 divided by negative 1 is a positive 1. So notice we end up with 3x plus 1 and 3x plus 1 as my common factor. So let's put those together. If I factor those out, I'm left with 3x and minus 1. 3x plus 1, 3x minus 1. Okay, what about x squared minus 16? Let's do the same thing. Just put a little line right here. X squared, we're missing the middle term, minus 16. I need two numbers that multiply together to be negative 16, right? 1 times negative 16 is negative 16, but add together to be 0. Okay, well, 1 1 and 16, well, negative 1 and 16, that adds up to 15. 1 and negative 16 adds up to negative 15. 2 and negative 8 would be negative 6. Negative 2 and positive 8 would be positive 6. 4 and negative 4 would be 0. 4 and negative 4. Okay, so this is, well, okay, understood 1 in front of the x squared. Remember, we can jump straight to our final answer. Put our x's in, and we have a positive 4 and a negative 4, so plus 4, minus 4. X plus 4, x minus 4. Okay, do you see a pattern? These are the same with the sign in the middle being different. The same with the sign in the middle being different. Okay, these are actually special cases. When you're missing that middle term, it's called difference of squares. Okay, difference of squares. So if you have something squared minus something squared, the result will factor, and you don't even have to really work it out. Basically the square roots of these, right? So a plus b, a minus b. Okay, in this form, I know it makes less sense. So let's actually go to an example here, like 64y squared minus 49. Think about 64y squared. What times itself is 64y squared? The answer to that would be 8y. 8y squared, 8y times 8y is 64y squared. Okay, what times itself is 49? 7, right? 7 times 7 is 49. 7 squared is 49. So this will factor as 8y plus 7, 8y minus 7. Okay, learn to recognize when it's a special case so that way you can jump straight to the answer. Okay, 16x to the fourth minus 81. Now this one's a little trickier because that's not squared, that's a fourth power. But this is true for any even power. Okay, any even power. 16x to the fourth comes from 4x squared raised to the second power, right? Think about that. 4x squared times 4x squared is 16x to the fourth, okay? And 81 is just 9 squared. So I can factor this as 4x squared plus 3, not 3, sorry, 9, and 4x squared minus 9, right? The 9 comes from there and there, the 4x squared comes from here and here. Okay, so usually we'd be done with this problem, but I'm recognizing this 4x squared minus 9 as another difference of squares. So I'm actually going to break that down. 4x squared is 2x raised to the second power, and 9 is 3 raised to the second power. So 4x squared minus 9 will factor as well. Let me bring down this 4x squared plus 9 so I don't forget about it. 4x squared minus 9 factors as 2x plus 3, 2x minus 3. So this one factored down quite a bit into 3 sets of parentheses. Okay, and then the last one, 25x squared plus 4. Don't fall for it, right? This is not difference of squares. This is a plus sign right here, not difference of squares. So we can't factor it using difference of squares. If I try to factor it the long way, I need two numbers that multiply together to be 100. 25 times 4 is 100. But add together to be 0. That's not going to be possible, right? 1 and 100 will add to 101. 2 and 50 will add to 52. 4 and 25 will add to 29. You'll notice a big problem here. You have to use two positive numbers or two negative numbers to get to 100, right? Positive 100. But you can't get to 0. There's no way to get to 0. Even if I made all these negative, I would just have the negative version of everything. So, turns out, it's not factorable. Again, not factorable yet. So anytime you have the sum of squares, for now, we'll just say that they're not factorable. Okay, and that would be our factoring expressions.